Hi, everyone. My name is Bhav Ashok, and I'm the founder of Nuron Labs. Nuron Labs is building a worldwide neural layer, which is a network of location-specific neural nets. And this will ultimately be essential in bringing fast and reliable neural nets to the real world. So why don't we have fast and reliable neural nets today? So let's consider what most deep learning pipelines look like. You have a bunch of annotated visual images. A large monolithic neural network is then trained on these images. And then the same network is deployed to every single user. So this approach usually works well for large-scale visual recognition tasks, like classifying videos of cats on the web, but it doesn't work so well when you apply it to the real world. So this is a typical example of what a segmentation model would look like in the real world. So you can see how it's kind of noisy, but it also makes some mistakes. So here it misclassifies the trunk of a tree as a tower and the flower pot as sand, right? So if you want to have robust augmented reality applications or safety critical systems like autonomous vehicles, we cannot afford to make such mistakes. If you want to do better than this, one possible solution is location-specific models. So here's an example of what the output looks like with a location-specific model. Here's a video showing the results, in somewhat of a real-time setting. You can see that it's a lot cleaner and a lot more consistent in its predictions. This is because the location-specific model captures the unique visual signature of the area a lot better than general model. So what exactly is the neural layer? The neural layer is a network of neural nets, which are each tied to a specific location. And these networks learn the exact distribution of visual data at that location. So for example, we can split a city like San Francisco into visually similar areas like parks, residential areas, and streets. And by deploying neural nets at each of these locations, we can actually get fast and reliable models that are guaranteed to work at that specific location. So how far are we in this process of building the worldwide neural layer? So in the last year, I published 2 research papers showing that it's possible to create a uniquely optimized architecture at a given location. One was published in iClear, and the other was featured in Pioneer. I've also started building the neural layer around the Bay Area. We've collected a bunch of images and location-specific data and trained a few models. And I've also launched, so I'm currently accepting users. If you're in the augmented reality space or the autonomous vehicle space, and this is useful to you, please sign up. Okay, so that's my presentation.
Sorry, I was muted. That's awesome and really exciting to see how much of an improvement the model is over more sort of the current state. I guess, why do you, in layman terms, why is it so much more powerful to sort of have this approach?
Right, that's a great question. So if you look at the way neural networks are usually trained, we get a lot of visually diverse data from a large distribution. So that's good for generalization. Mm-hmm. If you want your model to work in different kinds of objects or classes. However, look, the real world has a far higher entropy than the kind of images we see on the web, right? You have lighting, you have weather conditions which affect this. Yep. Each city kind of has its own unique visual signature as well. So all of these things come into play when you're using neural nets in the real world.
Interesting. And sort of, how did you get into this area? What was your experience like before this project?
Right. So I've actually been doing research in computer vision and deep learning since I was pretty young. But I've also had a lot of industry experience. I currently work at Google in Google Research. And I've also worked at Niantic, which is like an AR company, and a lot of startups along the way. And I've seen a consistent problem across all of these cases. The models don't really generalize to a real world setting. They work well in a small academic data set or for a nice prototype or demo. But when you apply it to the real world, you almost always have these inconsistencies in your data distribution. So it doesn't really work that well. It's a consistent problem.
Yeah, I mean, it's kind of a tricky part though to do it as an individual. Like in contrast to Google, where you can send out, cars everywhere and get all this local information. Like I like that you can sort of have this centralized approach and have more people contribute data, but how do you incentivize them to actually contribute the data? Like, how do you make sure that there's something in it for them, or they're going to be excited to participate?
Sure. So I'll actually share a slide real quick if I can figure out how to do that. Okay, so if you do an analysis on the amount of the population density of 1 kilometer square areas and plot them out, you can actually see that you only need about 50K neural nets to cover about half the most populated areas in the world. So this is not like an insane amount. This is still tractable, and it'll take about 5 to 7 years, right? And the reason most companies aren't really incentivized to do this is because they don't really capture the network effect component of this. So the moment you improve one area, you improve the surrounding areas as well. And for each customer, we have the network effects for this increases, right? For a single startup, they aren't really incentivized, since they're only going to use it once or iteratively. It kind of scales linearly as opposed to exponentially, which is what we have going for us here.
And so you're currently at Google. What's next for the company?
So currently I'm accepting users for my private beta. So, the product kind of works well in a few areas right now, but I really want to understand what the customers need and kind of help them build a model for themselves first, and then we'll scale after that.
Got it. And so you mentioned, if I remember correctly, self-driving cars and augmented reality as the customers that you're looking for right now. Is that right?
Yep.
Are there any particular, for people on the live stream, are there any particular customer intros that you're looking for that they could be helpful with?
Yeah, I mean, I wouldn't just, narrow it down to those two. Anyone who's using neural nets in the real world suffers from this problem. So if you think it falls under this category of problems, I'd be happy to help. Specific intros, I'm not sure who's on the live stream, so it's hard to do that. But, feel free to reach out to me. My information should be up on the website somewhere.
Awesome. Well, thank you for sharing, Bhav, and great to meet you. It's really exciting what you're doing.
Thanks, Dylan. Bye-bye.